Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong Learning Experience brought to you by Synopsys. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting panel ahead. Before we get this kicked off, we do have just a couple of housekeeping notes to cover. First off, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you want to engage with us, there are a couple of options for you to do so. The first option is the chat tab, which you can find on the right side of your screen. I'd like you to let me know that this chat tab works by letting us know from where you are joining us from. I know we have a global audience, and we'd like to see kind of where our audience is stemming from. If you do have any questions for John, we do ask that you send those into the Q&A tab, as that just helps us keep track of them better. We're probably going to hold most of the Q&A toward the end, so if you submit your questions, be patient, we'll get around to it. Also, if you click over on that handout tab, you will see that there are 2 resources there available for you, so feel free to grab those at your own leisure. And of course, before we close out, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our conversation today. Our topic is how to address API security in 2023. And I'm joined today by John Tapp, Associate Principal Consultant at Synopsys. John, thank you so much for joining me today. Do you want to go ahead and get this presentation rolling?
Great. Thank you for kicking everything off, Cody. And thank you, everyone, for joining us today. I'll be hopping off camera shortly to start the presentation, but wanted to let you know that I appreciate you joining us. And with that, we'll go ahead and get started. So my name is John Tapp, and I'm an Associate Principal Consultant with Synopsys. I've been consulting for 9 years, and over that time, I've conducted vulnerability assessments, threat models. I've helped companies build security champions programs. I've built out maturity action plans for clients, including helping them establish an enterprise API security strategy. Part of what I'll be talking about today will be discussing some of what we at Synopsys have learned as part of those projects. So let's talk about API history. Application programming interfaces were initially created in order to standardize the interface used to program applications. It's a fairly straightforward acronym in that sense, but what it has referred to over time has changed. So one example you're probably familiar with are language APIs like Java, which is an interface that allows you to access hardware devices or network sockets or other components. Then at some point, developers decided they wanted to further expose the APIs to their own programs so that others could build upon what they've already created. Those kinds of APIs enabled the creation of things like browser plugins. And then continuing that trend of wanting to further extend functionality to more people, we start getting to today's topic, APIs exposed over networks. Now, APIs start being integrated into web applications and leveraged so that it can support multiple types of clients, like mobile applications in addition to browsers. So at some point, developers realized they didn't just want to support end users, but also wanted to support themselves too. And that's where we start to get into what's new in APIs. We'll walk through a theoretical setup here of a streaming service with a couple of simplified examples. This streaming service may need to support multiple clients. So it, as an API endpoint, that works like a traditional web application for a login screen where it serves a pretty standard HTML form and resources. Now we've logged in and need to serve up a catalog to the consumers, and the streaming service is constantly making updates to improve performance and add new functionality and features. So they've decided to deploy a microservice or some kind of containerized API. This allows them to tear down and stand up new versions on demand without impacting the app server or the API that the consumer sees. Then, as a consumer, we select some content to stream, and cluster 2 comes into the picture. This cluster allows the streaming service to scale to address performance needs by balancing the load across the service mesh and adjust the scale as needed. So now we've got multiple services working in concert to ensure that video, audio, subtitles, and metadata are all being streamed to the consumer while keeping in communication with one another and the service mesh that supports them. If we look back at the leftmost example, you could look at basically one code base and figure out all of the security requirements and needs in a pretty straightforward fashion. But as more complexity has been introduced into this system, security isn't as straightforward as it used to be. And this complexity is pervasive through the modern web. Companies need to be providing flexibility to consumers, or else a competitor will take their place. So APIs are how businesses are staying competitive. That means API risk is business risk, and it needs to be understood and managed before someone attacks these APIs. At least in the US, this has all been exacerbated by a few things. Executive Order 14,028 highlights that anyone who wants to sell anything consisting of software to the US government must self-attest to their compliance with the Secure Software Development Framework, or SSDF. Additionally, the White House's National Cybersecurity Strategy, released earlier this year, it consists of 5 pillars, one of which is, quote, shaping market forces to boost security and resiliency, end quote. The text of that pillar is widely seen as shifting liability for the security of software onto vendors. Vendors who adhere to a safe harbor framework for secure software development, which, to be clear, has not yet been developed, would be protected from liability. But those who are not found, or who are found to not adhere, would not be shielded from liability. Additionally, the EU has also been making headlines with the Cyber Resilience Act, which seeks to establish common security requirements and supply chain standards for products with digital elements, broadly targeting both hardware and software products. Now, these efforts by the EU and the US are broader than just talking about APIs, but as we'll see shortly, APIs are a unique challenge, and despite what seems apparent, there is no single tool you can acquire that will address all of your API security needs. You need to look at a holistic solution that takes into account not just technology, but people and processes as well. So let's take a look at an anonymized case study from a breach I learned about online and break it down. Note that the architecture here is purely for illustrative purposes, and all of these details were shared publicly by the victim. So someone managed to access a server and discovered credentials. Those credentials gave the attacker permission to access another RESTful API server. And the attacker was then able to access non-financial details about millions of clients, including the passwords they had stored in a database hashed by SHA-1. While all of this was occurring, the business had received an informational alert that an unauthorized third party had gained access to that initial server. So, by looking at this breach, we can identify a number of issues that need to be addressed when moving to an API-oriented architecture. We already covered in the slide before that the attacker was able to gain unauthorized access to a server and then repurpose a compromised token for gaining privileges with an internal API. This kind of identity and access management problem is going to be a huge problem going forward, particularly if you're dynamically spinning resources up and down to scale with demand. APIs are going to need to have a reliable way of determining who should have access to what. This applies to both the traditional north-south traffic we expect to be flowing across your traditional trust boundary in and out of your network, but also the east-west traffic that flows within your environment. The dynamic nature of an API-oriented architecture also means that backend services may not be calling long-standing endpoints that you inherently trust. It may be a recently spun up endpoint you've discovered from a service registry, and changes have been made to it or the system of record it pulls from. This means your API is going to need to validate that the data it is receiving, both from the calls it is receiving from consumers and that data it is pulling from the backend. This includes the content of the data. So does an integer field have an integer? The format of the data schema is the data valid JSON structured like you expect it to be, and any signatures like those included in JWTs. As I've mentioned, these APIs may be spun up and down dynamically at various points in the architecture, and ensuring that they're securely configured is also crucial to hardening against attacks. A single weakness could easily be propagated across your environment, and once detected by an attacker, could result in the attacker moving anywhere that weak configuration is in place, furthering their foothold. This applies to everything that goes into standing up your production environment, from architecture patterns all the way to your infrastructure as code. It would not be surprising if, in our case study, that server that acted as the foothold had some kind of weak configuration that allowed the attacker to gain access to the API token. The data that the compromised token provided access to may have been protected by a cryptographic control, but that only goes so far when the control, SHA-1 in this instance, is ill-suited to the task. Beyond protecting passwords, like in your traditional AppSec context, when dealing with APIs, you may need to examine additional steps like management of API keys, like the token we talked about earlier, and data tokenization as well. Finally, we get to active monitoring and alerting, where again, our case study had some controls in place that helped, but only so much. It is great to have a system that's able to keep track of what's happening, keep a record of it, and raise alerts for someone to look at. But realistically, with the current landscape, you have to do more than just watch and review. Simply dropping a web app firewall at the boundary isn't sufficient. Due to the scale and ephemeral nature of APIs, more actionable outcomes are required now than ever before. These events that are being monitored and the alerts being thrown need to be dealt with through automation, because otherwise teams are going to be buried in noise and things will slip through the cracks. So it is crucial to give automated tools access and agency within the environment to stop problems when they can be reliably detected. All of these different sets of issues combined now need to be addressed at various stages of your SDLC and throughout your architecture. Realize I've highlighted these issues in certain spots in this diagram, but all of these issues are pervasive. It is not localized to one particular area. Great. So I've highlighted a lot of challenges, but what can or should you actually do about all of this? Well, the first step is figuring out what gaps exist in your current SDLC between how you secure web applications and how you secure APIs. To start off, you have to look at governance within your organization, in particular, focusing on risk management and visibility as it relates to your APIs. Next, ensuring that you have adequate testing for your APIs. And finally, reviewing the security controls that are operationalized in production. So governance is a key element to investigate because it is fundamental to how your organization operates. Ensuring that your development processes are able to help you address API-specific needs, and that the organization has the capability to train people internally to develop API security expertise. As part of this effort, you need to evaluate how your organization currently manages risk. This includes looking at all of your SDLC controls and making sure that they can support your API development efforts. This generally shouldn't be too much of an issue for traditional defect discovery activities like threat modeling, static analysis, or composition analysis. These activities can also help you figure out a standardized set of architecture patterns with approved libraries and frameworks that help ensure you're using the best-in-class solutions to help you design and build your APIs as securely as possible. However, you also need to consider everything else that your APIs are built on top of, like the cloud components, containers, cluster orchestration, and anything else that those are all, to ensure that those are all securely configured. Having all of this lined up for your team can help you with the visibility problem. One of the benefits of APIs being put out there is that they can be reused for many different purposes. But that reuse can only happen if you know the API is available for consumption. This means you need to have a way to publish and track your APIs so that people can discover it and start using it. However, the gap between discovering and using APIs can be quite significant, more significant than it is for web applications. One of the main reasons is that you can't necessarily just explore an API through a web browser by default. They aren't designed for navigation like web applications. However, if you have API documentation, you can now provide that alongside wherever you've published the existence of your API internally. Ideally, you have some kind of registry or management platform that allows you to then track this documentation so you can keep an inventory of all your APIs. This all sounds like a lot of work, but it is crucial to figuring out what is out there on your network. And this could be a vision for future automation, a future where maybe you have a code base that has comments dotted throughout, which is then analyzed to generate machine-readable documentation as part of your build process. Your pipeline then conducts tests using that new documentation, publishes it to some internal API marketplace for others to grab, or maybe it gets deployed along with your API and is leveraged by a sidecar or API gateway to help others understand how to call your API. This kind of visibility is crucial to securing APIs because in order to secure your APIs, you have to have adequate testing. And this testing must go beyond your standard unit integration and functional testing. Contract testing and security testing needs to be in place too. In order to have a contract to test, you must have some kind of machine-readable documentation. This could be a WSDL or WADL, that'd be web services or web application description language, which has lately fallen out of favor. An SDL, schema definition language for a GraphQL endpoint, which is useful if you're not allowing introspection, or an open API specification that'd be used by more modern RESTful APIs. This documentation is structured so that you can clearly define how to make requests to all of your endpoints and what you can expect to receive in return. It also acts as the contract between your API and consumers. Consumers expect that if they follow your documentation, they'll get a response back, and that matches what you've declared as expected responses. Having robust documentation makes it easier for your users to know what they need. And if it is in a machine-readable format, like one I've mentioned earlier, you can automate testing to ensure that the API is behaving as expected. By testing this contract, you're verifying all of the claims in your documentation, and that can help ensure that you can effectively implement your integration, functional, and security tests, giving you an early warning if any breaking changes or changes in behavior are made. After all, if your documentation doesn't match implementation, then your documentation isn't doing you much good. Having your contract testing in place then allows you to proceed with automated testing for your API with confidence. Now your API security tests can help determine if it is able to break out of any of those behavioral expectations. There's a huge ecosystem of tooling that supports the Open API specification standard. and can help enable automation of testing like this. But be aware of your traditional security testing tools, because while they may be good at finding SQL injection, particularly in web applications, they may not be ready to identify API-specific issues like broken object-level authorization. The same is true for your production controls. If you're relying on web app firewalls, which were built for web applications and have just tacked on API security to check a box, traditional WAFs can catch some attacks, but assume the context is against browsers and servers, just like traditional DAS tooling. Web applications and API protection solutions, also called a WAP, are a next-gen WAF that considers APIs as well. Simple attack signature analysis is not sufficient, and WAPs can help look at your open API specification or equivalent machine-readable documentation to help identify traffic that is malicious. However, there's more to protecting your APIs in production than just buying a solution to sit in front of your APIs. When looking at your production controls, you really need to look closely at how you're logging. This includes what you're doing with errors, exceptions, and events from the API. And also the container, the orchestrator, the cloud platform, all the elements of the tech stack up and down your production system. These logs then need to have some analysis done on them. And that's where some new tech may need to come into play with helping to interpret these events to determine if an attack is underway to compromise the system, a bot is using the API, or maybe someone is attempting to exfiltrate sensitive data. And now that you've got this interpretation set up, taking some kind of action. Sure, the easiest option, it may be to raise an alert, but for some scenarios, it is realistic to enforce at least some kind of traffic throttling, if not even blocking of traffic, that is clearly malicious. Potentially, you may even be able to identify that an attack has already happened and can even kick off some kind of incident response automation to collect all the information you need and revoke access, or maybe spin down impacted systems as warranted. With all that said, let's take a little bit of time to look back at our case study and see how some of this may have played out a little differently. If there was proper application of a secure configuration, would the attacker have been able to gain access to that original server? The company here highlighted that in order to address configuration issues, they redoubled their efforts around traditional AppSec tooling. They started looking at design patterns to ensure people used known secure configurations, and started to document approved libraries to minimize the risk of unknown vulnerable libraries being used in production. This resulted in a significant reduction in their legacy code base and removal of potentially vulnerable dependencies, overall shrinking their attack surface going forward and making the code base easier to maintain with deprecated code and logic removed. If the API was applying IAM restrictions properly, would that compromised token have been valid for escalation privilege and access beyond the defined scope? Well, now the company is forcing token rotation for API clients. Tokens now only last a couple of days rather than indefinitely. End users were forced to change their passwords and had multi-factor authentication now enabled by default on their accounts. There was also a review and overhaul of entitlements used throughout the company where they ensured that they were implementing the principle of least privilege. This has included reducing the overall access that employees had down to the bare minimum to complete their jobs so that their credentials are less useful to an attacker than before the breach. If they were properly applying cryptographic controls, would their sensitive data have been as vulnerable? API keys, as I mentioned earlier, are now forced to rotate periodically, but also sensitive information is now being tokenized. Previously, account information like names and emails were regularly being passed around different services. But all of that sensitive information is now simply replaced by a client ID. This reduces the exposure of the information to other systems and allows them to further restrict usage of account information to only scenarios that really require it. If the active monitoring and alerting were configured better, could their solution have noticed non-baseline behavior and prevented an attack rather than just reporting an alert? The data tokenization also allowed them to restrict access to account data. So that its usage now makes it easier for them to track when services are using it for what. Now they can effectively monitor and raise alerts when there's peculiar activity, like someone attempting to access data outside of standardized processes. So they also took the step of setting up a SIEM so that they can track these events and correlate them more effectively with a dedicated team. If there was adequate testing of issues like data trust, would they have uncovered this vulnerable server or any of the other intermediate steps that took place before the breach? The business had the unfortunate lesson that they had to conduct testing against their own systems or someone else would do it for them. They now have a team dedicated to conducting security testing in order to find problems. This, along with the overall response to the breach, resulted in a huge increase in security awareness at their company, increasing everyone's vigilance. So what works? Well, let's start with what you should be wary of. Treating APIs like just another web application, as we've seen, can leave gaps in processes and technologies that could weaken your security posture. The other thing I'd like you to consider is that APIs are complex, and buying a silver bullet solution may provide part of your API security strategy, but isn't going to address the whole picture. So with APIs being deployed at such an incredible scale, ensuring you're secured through planning and automation is a must. This means that they need to be secure by design and documented, and that documentation can help you build an inventory, publish it, at least internally, and get people using your API quickly and reliably. Over time, you may be able to leverage your CI/CD pipeline to automate document generation. That documentation then enables security tooling to help automate your testing. Most of your security tools should work just fine, but be wary of traditional DAS tooling. A potential weakness is that traditional DAS tools were designed for identifying software vulnerabilities in applications where the primary interface is a browser. When securing APIs, we need to consider other contexts like mobile, desktop clients, and especially automated internal and external business-to-business use cases. All have different security contexts beyond what is considered with the browser, and what may be fine for one isn't necessarily okay for the others. This further compounds because traditional DAS engines were designed to crawl and invoke functionality automatically in web applications. APIs require you to have monitored traffic so that the tool can then replay for fuzzing or documentation like an open API specification that is well defined enough for the tool to be able to automatically ingest that and then send valid requests with, as well as finally comparing the response it gets back with what you have actually already documented. This documentation then can be used to, again, make calling your APIs easier for consumers. It can also be leveraged by API security solutions like those web application and API protection solutions I mentioned earlier to enforce a positive security model where they know what traffic should look like and block traffic that doesn't adhere to that. Of course, there are other solutions which will attempt to learn your API's behavior, but ultimately, knowing what you're expecting and enforcing that from the start is ideal. And this isn't to overshadow what I was talking about earlier with having robust logging approach that allows you to monitor what is going on with your APIs. That is going to be crucial information even with one of these WAPs, because you'll still want to have any API behind that solution or any other protection to be robust enough to resist an attack that bypasses those controls. Ensuring you have defense in depth, which is critical to any effective strategy. And when it comes to strategy, Synopsys does have services and tools that can help you develop your API security strategy further. Consultants like myself can work with you to develop a comprehensive plan to mature your organization's approach to securing your APIs. Review the design of your APIs to identify risks, and provide instructor-led training so that you have the in-house expertise needed to secure, defend, or attack your APIs. We can also work with you to help you discover what APIs already exist to help build your inventory and conduct assessments of your APIs either through our services or the Seeker IS tool, which can both provide you with effective remediation guidance to fix what we found. Thank you for your time. If you'd like to see some other resources, as Cody mentioned, there are handouts attached to this presentation. And with that, I'm happy to take questions. Cody, do you want to take things from there?
Absolutely, John. So I do just want to call for everyone to send in any questions you may have. We do have just a couple to get us started. So John, can you test API security without the API documentation?
So testing APIs without documentation is incredibly challenging. If you don't have any documentation at all, whether machine readable or human readable, it's quite challenging. You would need to find some other method of observing what those API calls look like. So that may be if you have a single page application, let's say, that invokes some of your APIs. You can monitor the traffic that your browser is sending to invoke those APIs through the JavaScript and try to test the APIs that way. But knowing it's difficult to get a complete picture of whether or not you've actually tested all of the APIs that single page application could invoke, or all of the APIs that you have theoretically written and could be invoked, but there's no way from a third-party perspective for you to definitively say, I know I got 100% of your endpoints tested without that documentation. So documentation makes it, raises your confidence significantly that you've tested the APIs completely.
All right. So John, what makes APIs so attractive to hackers?
So I think in no small part due to the explosion in the number of APIs that are out there and the relative immaturity of the industry with securing APIs and the complexity that goes along with securing those APIs. As I highlighted early in the presentation, you're moving from a single code base with a single interface to maybe a single interface, but multiple code bases behind it. And ensuring that you have every point in that system secured is incredibly challenging. So attackers know that it's not exactly the law of large numbers, but due to the sheer scale, the likelihood of them being able to find a gap is, they feel confident that they'll find something useful.
Can zero trust architecture ensure API protection?
I just realized I forgot to put my camera on. So zero trust is something that can help. Yes, it's not going to, as I highlighted, there's no single solution to ensuring this, but following a zero trust model can certainly help with your security posture. When I was talking earlier about data trust, for example, you need to be able to validate both the requests that you're receiving as well as the data that you're pulling from your backend services. So you can't necessarily trust the information you're getting from either. You need to validate that all the data you're getting and passing along adheres to the expectations that your API documentation theoretically should be outlining.
Well, all right, if zero trust can't secure our API protection 100%, can shift left practices secure our APIs?
Shift left is something that will be able to help, again, your security posture, where back in when I was talking about planning, you need to be able to set up your documentation. And then if you have that documentation early in your process, you're conducting architecture reviews to verify who's going to have access to what, who needs to communicate to one another. You're then going to be able to help with then moving through your SDLC more confident and with more automation to be able to justify that with a more confidence that you've got additional, you're more confident that you're in a good position, basically.
So another question that we often get is that no team in particular really wants to take responsibility for who is responsible for API security. So who do you think should be accountable for that security?
Yeah, it is a cross-functional effort. Security is, I'm sure everyone's corporate training has told everyone, security is everyone's responsibility. And that doesn't, unfortunately, change with APIs. It really is something where you need to have multiple people at the table, all the stakeholders on the same page about what's going on. A number of clients have some kind of application security program or software security organization at their company, and that is a key group to have help direct the security strategy for APIs. But as I outlined in this presentation, making sure that APIs are treated appropriately relative to web applications, where you can't just assume that your web application program is going to handle your APIs sufficiently, since there are unique challenges and you may need some unique tooling set up. But some of that will be facilitated by being able to set up that automation I was talking about, where you've got your contract testing, you've got your unit, your functional, your integration tests, and automating security tests in that same pipeline as well.
Awesome, John. Thank you for that. We do have kind of a longer question from participant 630. John, if you wouldn't mind just hopping into that Q&A tab and taking a look at it. Meanwhile, sure. I will put it up on the screen and read it out loud while you take a look at it. So, hello, in the setup below, we control all of the processes, parentheses, we control authentication, authentication server, resource, and clients. In a backend for front-end setup using OAuth 2 code grant with PKCE setup, does a React front-end client need to be verified if there is a backend PHP proxy acting on its behalf to make requests? Or is it that since the PHP proxy, which holds the secrets, generates code, challenge, verifier, etc., handles all of the communication with the auth server and resource server, we don't need to verify a React client? John, you got any insights for this question?
So it sounds like this is a pretty standard Pixie flow where you've got a backend proxy. In this scenario, it sounds like this PHP proxy on the backend is handling a lot of. I'm not entirely sure its role. It sounds like this is acting as part of the identity provider role. But it's I like to work visually with these kinds of problems, specifically due to the many different people acting in this this setup. Let's see.
And participant 630, if you do have any more context you'd like to throw in, feel free to send me a message. We can get that thrown in as well.
I would hesitate to say that you don't need to verify the React client. But unless we, had a better understanding of the use case and the clients, the access to the React client and who the users are, and that it's tough to make an appropriate evaluation based on that context that I have, at least. I'd be happy for you to reach out to me. I gave my email early in the presentation, and you could reach out and see if you could give me some more details, and we can see if there's something that I could point you to give you some better guidance or not.
Sure. It looks like they just sent me a kind of brief version of the question, but does a React client basically generate the code challenge and code verifier, or is it the backend?
Standard OAuth 2 code grant with Pixie setup, I would assume that would be the responsibility of the identity provider to handle. And it sounds like this proxy is kind of sitting alongside sitting between both the resource server and the auth server. So it's one of those things where the handoff and responsibilities is a tricky line. I don't want to necessarily give incorrect guidance from my limited understanding in this context.
All right. Well, John, it looks like we do have one more question with us, and it is brief. So do you have any options for multi-factor authentication?
I mean, so multi-factor authentication, I would highly recommend taking a look at the NIST documentation on authentication levels. Essentially, you have three options for authentication. You've got something that you know, typically a password, something that you are, frequently fingerprint, and something that you have, which would be a security token of some sort. That being said, I mean, there are so many different vendors out there who have different options. It's tough to say that one is definitively the way to go because there are so many different avenues that you can take. I will say using something like two-factor authentication through text messaging, not ideal because we know that text messaging is not a perfectly secure system compared to other systems like using a fingerprint on your phone, for example. That using your fingerprint on a phone is much more hardened setup, or if you could get a push notification from some kind of authenticator app, things like that would be a better approach than SMS.
Awesome. Well, John, so we have exhausted our questions, but I do want,
I do see one other.
Yep. Is there any community edition version of the API security tool from Synopsys?
So by API security tool from Synopsys, I presume you're referencing the Seeker IAST tool that I mentioned for this. And I don't believe that there is a community edition of that specific tool. But the you could certainly reach out to see if we could set up a trial or something of that nature.
All right. It seems the questions are going to keep rolling in, so we're just going to keep tackling them. What are some common API security oversights?
Oversights in API security. So I think probably one of the largest categories of issues, I'll say two things. Identity and access management is a huge one. As we saw in the case study that I brought up, they allowed, they had someone who was able to access a server unauthenticated, and as a result, they were able to steal a token from that server, and that token could then be reused. If you look at API security news stories, identity and access management is almost always one of the examples, one of the issues that are highlighted. The other one, which I think is maybe overlooked at large by the industry, is excessive data exposure. I think it's a huge one. There are an incredible number of APIs out there who have so much data being returned when only a subset of that data is required. And that was actually something that was highlighted as part of this case study, where the company realized that they were passing around names and email addresses and all sorts of information, when really all they needed was to tokenize the data to a client ID, and that client ID was going to serve 90% of their purposes. So they were able to then stop sending account information around a lot. However, I will say, I think if I were to highlight one thing that could really help address that kind of issue, I would point to documentation. Again, I think documentation is by far the most powerful tool that you can put into place as a developer. Having machine readable documentation that's complete, where you know exactly what you're expecting to receive in a request, validating that you are getting that data and not additional pieces of data added to the schema to avoid vulnerabilities like mass assignment, and then knowing exactly what kind of data you're expecting to then send in response to that, I think is the other key element, because that will allow you to validate that you have the server, your API, actually returning the data you're expecting it to. It will allow you to then audit what data is being sent to avoid excessive data exposure. And it will further enable you to be able to set up automated security controls, either through security testing or through those production controls I highlighted earlier, where you can implement a positive security model restricting anything that doesn't adhere to that documentation you've declared.
All right, John, thank you so much for running through all these questions with me. As we do start to wind things down, I do want to give you one more chance to leave our audience with any parting remarks or anything that you feel they absolutely need to walk away from this program knowing.
Yeah, I think that the ensuring that you have the documentation is really crucial. And then if you're in a position where you're helping your business manage its security program, having a way of inventorying that documentation, whether that's through an API management platform or through some kind of marketplace that you host for your teams to be able to share their documentation, being able to inventory all of that documentation is the two most actionable items I think that I can direct people to.
Awesome. Well, John, thank you so much for bringing everything that you've brought to the table. I know this is we are ending this maybe 10 minutes short, but I feel like I've been learning from you for about an hour and a half. So thank you so much for being here with us.
Great. Well, thank you. I appreciate that.
So to our audience, I'd just like to remind you that you will be receiving a version of this recording on demand. It will be sent to you via email, and it will be sent to you shortly after we conclude this session. If you don't want to wait around for the recording, or say you don't happen to receive that email, you can also find this thing on the DevOps website at devops.com/webinars. And just be sure to look in the on-demand section. It should be there here in just a couple hours. The 4 winners of our $25 Amazon gift card drawing are Jennifer G, Mohammed S, Samya J, and Lisa M. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. You should receive that in about the next 48 hours. If you don't happen to see that, just check your spam folder in case it got filtered out. I'd like to thank Synopsys for sponsoring our program today. And to our audience, if you're hearing my voice, thank you so much for being here. We really appreciate your time and the time that you spend here with Techstrong Learning. And we just want you to stick around with us for 1 more minute. As soon as we close out of this program, there will be a survey that pops up on your screen, and we would love to hear your feedback. So tell us what you thought about this program today, or if maybe you have recommendations for a future program, we'd love to hear from you. Either way, we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day. And John, thanks again for joining me.
Thank you, Cody.